Hi, these are notes on delta H or enthalpy calculations. You will want to grab your thermodynamic packet or open it up before you view the notes. So we're going to be calculating delta H. Before we do that, let's just review a little bit. Delta H enthalpy change is how much energy is being absorbed or released by a system. So absorbed from the surroundings into the system, or from the system back out to the surroundings. And we represent this with a delta H. So this is the new part. The molar heat or enthalpy change of formation. And this is something you can find in your thermodynamic packet, page 1. This is the amount of energy that is going to be, the amount of energy change when 1 mole of a compound is formed. So that's why it's formation, F, from its elements. So elements aren't really formed, they're not compounds with those bonds. So the delta H of formation for any element, like for example just plain copper or a diatomic molecule like oxygen, that's going to be equal to 0. By the way, if you see this symbol, this just means standard state, which is standard room conditions, 25 degrees Celsius, 1 atm. And then the little f just means it's the amount of energy involved in the formation of 1 mole of that substance. So those aren't really going to affect any of your calculations, but when you see them, sometimes they're there, sometimes not. That's all it means. So this is page 1 of your thermodynamic packet, which I want you guys to have out, and we're going to refer to this as I keep talking to you. So one thing, so when using page 1 of your thermodynamic packet, if you find that a substance has a negative delta H, that's the amount of energy that's going to be released when 1 mole of that compound is formed, and it's an exothermic process. The larger it is and the more negative, the more stable that compound that is listed is. So for example, the H2SO4 liquid is negative 814. That's very, very stable. Iron 3 oxide here, negative 824.8, is very stable when a mole of that is formed from iron and oxygen. And then the reverse is true. So if it's a positive delta H of formation, it doesn't mean that that substance will not form. It's just going to be something that's more unstable. So if it's positive or just barely negative, then it's going to be something unstable and likely to react and do something and form something else. So for example, let's see, like silver sulfide is only negative 31.8, so that would be much more unstable than something with a huge negative heat of formation. I want to show you guys a video.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
So I think I've shown you that video before. I want you to just think about, is that reaction endothermic or exothermic? Do you think the delta H is negative or positive? And what is the heat of formation of sodium chloride? You can look that up now on your packet on page 1. What would the enthalpy diagram look like? So think about that. Maybe pause the video while you do. So that reaction, I think, was obviously exothermic. They added the sand because otherwise the heat generated would have cracked the glass, which tells us without even using the chart that this is going to have a very negative delta H value. And in fact, when you look it up, it's negative 411.2 kilojoules. So the enthalpy diagram is going to look, let me make that a little bigger, like this, where you're going to start with the reactants having more energy, the products having less, so this difference in energy is let out. So I would have arrows pointing out into the surroundings from that system. So, you get to hear my dog bark again. So anyways, we're going to do some calculations now where we can calculate delta H of the whole reaction by taking the sum of the heats of formation of the products minus the sum of the heat of formations of the reactants. So this little this Greek letter is, I think it's epsilon, I can't remember, but or sigma, I lied. It means the sum of. So in the next video, I will show you how to use that.